This begins EE 544 with Professor Zahid on Tuesday, February 18th, 2014.
Thank you very much. Good afternoon, everybody. Okay, now let's continue our discussion from last time. Before we start with the link budget analysis, I wanted to understand, apparently you are still confused a little bit with this. So do not write anything. I will be posting this and you can download it. I want you to understand it carefully. Apparently you are struggling. First of all, can you zoom in please a little bit? Perfect. Okay, let's understand these parameters, which is called what? The dynamic range, the spurious free dynamic range, the MDS. MDS stands for what? The minimum detectable signal, and so on and so forth. The noise floor, all of these parameters, I need to make it clear. I need to make sure that it's very clear in your mind. Clear? Okay, so what do I have? This is the characteristic of what? Of the amplifier. Is it linear or nonlinear? Most of the time, it is what? Linear, but at the input level. What is the axis? Let's understand the axis. The axis is the what? Input power, and the output, this axis is what? Is the output power. Clear? Clear? Okay. Both of them are in what? In dBs. When I say dBs, what does that mean? In dBm. dBm. Did you understand that or not? Listen to me. If somebody tells you the power is in dB, automatically it means they are telling you that it's what? In dBm. They don't need even to say dBm. Once they tell you that the measure is in dB, that automatically means what? Either dBm or what? dBw. Did you get this or not? But when you write it on a piece of paper, you need to be careful. Clear? Whether it's dBm or whether it's what? dB. Clear? Oh, so this is all what? This is all, help me, in dBs. Clear? dBm. Okay. Now what do you see? This line, what is the slope of this line? The slope of this line is 1 to 1. Yes? The slope of this one is what? 3 to 1. What does that tell you? It tells you that this is the characteristic of what? Of the third order intermodulation product. Third order intermodulation product. We already found out that the slope is what? 3 times. Yes? How, by the way, speaking of this, if the question give you the second order, instead of the third order, what would be the slope of this guy? 2 to 1, which means what? Will it be this way or will it be this way? This way, which means what? The intersection with the linear portion, will it be higher than this point or lower? It will be higher. That point where it intersects is called what? IIP2. Clear? As related to the what? To the input. Are you following me so far? Okay, now, so this is the curve. This is where they intersect. It's called what? IP3. If you measure it from the input side, it's called what? IIP3. The first I stands for what? The input intercept point, third order intercept point. If you look at it from what? From the output side, then it's called what? OIP3. And what is the relationship between them? The relationship between them is what? Is that they are separated by what? By the gain of the amplifier. Clear? In other words, IIP3 plus the gain in dB gives you the what? The OIP3. Are you following me so far or not? Okay. Now, one more parameter before we get to the details. What is this? The way, the point in which the linear characteristic differs from the actual characteristic by what? 1 dB is referred to it as a what? The 1 dB compression point. Again, you can measure it at the input side, which is what? Pin 1 dB, yes or no? Or you can measure it at what? At the output side, PO 1 dB, yes or no? Question, how are they related? No, 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 no. Let's see if you can help me. PIN, compression, sorry, what is it written here? 1 dB, compression, equal to what? P, O, 1 dB, yes or no? Help me. Minus G. Do you understand where this plus 1 came from? Yes or no? Why? Why? It's 1 dB loss. See, the G is the gain of this guy. Did you understand that or not? In other words, if you take this and you go all the way to what? Here, that will be the what? PO 1 dB, but you need to go what? 1 dB what? Below it. Yes or no? Cannot hear you. Yes or no? So this is the relationship between them. Clear so far? Clear so far? Okay, good. Now, what is this level? Do you see this level? This is called the what? The MDS. What does the MDS stands for? The minimum detectable signal. However, if the question does not give you the minimum detectable signal, you treat this one as the what? The noise floor. They call it the what? The noise floor. I will show you that in just a second. Did you get my point? If the question does not give you any detail about the signal to noise ratio, in the industry, in the RF industry, the MDS is usually taken to be 3 dB above the noise floor. Did you get my point? Are you losing me? 3 dB above the noise floor. Now, the first question we need to ask ourselves is, how do we calculate the noise floor? I will show you that in just a second. Did you get my point or not? But if the question gives you the signal to noise ratio, as I will show you in just a second, then you need to take the MDS rather than the what? Rather than the noise floor in calculating the what? The dynamic range. Now, let's see, understand. What is a dynamic range? Sometimes they call it the linear dynamic range, and sometimes they even call it the 1 dB compression dynamic range. The 1 dB compression dynamic range, to emphasize that you are looking at what? The point in which the amplifier start what? Compressing by how much? By 1 dB. Did you get this or not? Yes or no? Yes. Okay, now listen to me. What is it? It's the what? The dynamic range. It is the difference between the what? Between, in other words, the dynamic range. That is called the what? Linear. Dynamic range is equal to what? Pn 1C. Do you understand? What is it written here? 1 dB, sorry. 1 dB. Yes or no? Minus the MDS on which side? On which side? On the input side. Which is which one? Which is this one? Which means what am I? Oops, what happened to the curve? Which is what? From here to here. Did you get my point? Yes or no? From here all the way to what? Here. Did you get it or not? Or you could measure it on what? On the output side, what will it be? From here to where? Here. In other words, from here to where? Here. Did you get my point or not? Yes or no? No response. Yes or no? Okay. However, if the question does not give you the MDS, you replace this by the what? The noise floor. Are you following me on that? The noise floor. Now, if you add the 3 dB, which is fine. Are you following me on that? In other words, noise floor plus what? Plus 3 dB. Did you get my point or not? Yes or no? Now, in the midterm, I will give you all the details. In other words, I will not allow you to make assumption of your own. I will make the assumptions for you. Did you get my point? Okay. Now, what is the spurious-free dynamic range? Let's understand the spurious-free dynamic range. When the what? When the third order intermodulation component power is the same as what? The MDS. Are you following me or not? Is the same as the MDS. Or if the MDS is not given, is the same as what? The noise floor. That is the point where we can neglect the what? The third order intermodulation, which means what? We say that the third order intermodulation component looks to us like the what? Background noise. And we can live with the background noise. Why? Because there is nothing in the world without what? Background noise. Background noise is always there. Do you understand that or not? So they what? They take from this point all the way to the what? To the intersection with the what? With the characteristics of the fundamental, of the amplifier. Did you understand that or not? How? Let's do it geometrically. Simple geometry. Simple geometry. I want to see this ABCD, all of these ABCD, so that you can follow it. What do I want? I want to find AB. Yes? What is AB equal to? Geometry. Geometry. What is AB equal to? AB is equal to BE. Do you agree? Why? Because the slope of this guy is what? Is 1. Yes or no? So what do I write? AB equal to what? BE. Clear so far. What is BE equal to? What is BE equal to? BE equal to what? ED or DE. So this is equal to what? DE minus BD. Are you following me so far or not? Yes or no? What is BD? BD is 1/3 of what? CD. Did you get it or you lost me? Yes. Why is it 1/3? Because the slope of this guy is what? 3. So BD, so this one is what? DE minus 1/3 is CD. Agree? Agree? Oh, no response. Agree? But what is CD? What is CD? Is it the same as DE? Why? Because the slope of this guy is what? Is 1. Yes or no? So what is this? CD. What did I say? I messed up. DE, sorry. DE minus 1/3 DE. Do you agree? Which means what? What is AB? AB is equal to what? 2/3 DE. Agree? Yes. Which is what? 2/3. Open the brackets. What is DE? DE is PIN 1 dB, the compression point measured at where? At the input side, minus, did I mess up? No, I'm sorry, I messed it up. IIP3, which is this point, yes or no, minus what? MDS in. I want you to, can you zoom back please a little bit? Did you lose me? No. Did you lose me? No. Okay. Zoom back please a little bit. No, zoom back. Out. Yeah, zoom out, sorry. Okay. I'm sorry, my mistake. I want you to see the linear dynamic range. It's what? PN 1 dB minus MDSI, whereas this one is what? 2/3 IIP3 minus what? MDISI. MDSI. In other words, is this the same as this? Yes or no? Okay. However, which one is bigger? This one or this one? IIP3 is bigger than what? Than PI by roughly how much? By roughly 10 dB. Yes or no? Okay. But keep in mind that this one is multiplied by what? 2/3, whereas this one is not multiplied by 2/3. Did you get my point or not? All of these are in dB. So in here, what do you substitute? This is in dBm. This one is in what? dBm. Did you get my point? In other words, don't change it into the what? Into the non-dB. Plug it in, and the question will give it to you in dB. Did you get my point? Yes or no? Now, let me ask you a question. If I want, what is this, by the way? What is the AB? Is the spurious free dynamic range. Are you following me on that? Is Professor Steer's book, he used these, what? Interchange, I mean, one in a place of the other. Are you following me on that? Boo-boo. He is making a boo-boo. Are you following me on that? So I need you to understand this. Clear? If in the exam, I ask you see in here to find the spurious free dynamic range, which component was I interested in? I was interested in the third order intermodulation component. If I tell you, find the SFDR, the spurious free dynamic range, based on the second order intermodulation component, yes? Can you tell me how will this change? This becomes what? IIP2. What else changes? This, instead of 2/3, it becomes what? 1/2. Did you understand what I just said? Yes or no? Convince yourself. I'm not going to show you the derivation. But the derivation is exactly the same as this. You sketch a what? A line with slope of what? 2. And you repeat the analysis. Clear? Yes or no? Okay. Now, let's get to the, did you understand this so far? So far. Now, let's get to the issues of the MDS and the what? The noise floor. The noise floor. Let's start with the noise floor. How do you calculate the noise floor of your receiver? This is your receiver. So the noise floor and what? MDS. The noise floor and what? MDS. Okay, notice, by the way, sometimes the MDS, they call it what? The receiver sensitivity. Clear? The receiver sensitivity. Remember, MDS is a measure of what? How weak the signal can be what? Detected. The weakest signal that can be what? Detected. Clear? Remember, dynamic range is a what? Range from what? The highest power that can be what? Processed minus the what? The lowest power. Are you following me or not? Okay. Now, let's start with the noise floor first. I have an antenna. The antenna is at temperature what? T sub A. That will be given in the problem. Are you following me or not? That T sub A will be given in the problem. Then I have the what? The front end. In the exam, I will break this one into what? Blocks. But in this discussion, I'm going to assume it's just what? One block. What do you have on this? Excuse me. You have the what? The G, which is the gain. Yes? The F, which is the what? The overall noise figure. Are you following me or not? Now, either F or what? NF. Did you get this or not? Yes or no? The question most of the time will give you what? NF in dB. So let's write it NF. I don't want to write NF. Is it F okay? Okay. Are you confused? No. What else? D equivalent. Did you understand that or not? Okay. The output of the front end will go to the what? This is referred to as what? The detector. Or if you want to call it what? Demodulator. Yes? Here, I'm going to call it S over N at the output. Better yet, write it like this. N S0 over what? N0. One more time. When you see it S0 over N0, this N0 is not the power spectral density of white noise. Yes or no? For white noise, let's see if you remember. For white noise, this is omega, sorry, this F, and this is Sn of F. White noise, what does it look like? It does not look like a constant. It is not Picasso. Did you get it or not? What is the level? N0 over what? 2. This N0 has nothing to do with this. Did you get this or not? This is the noise power. This is in what? This is the noise power in watt, whereas this one is what? Is the noise power spectral density, which is in what? Watts per hertz. But I'm running out of symbols. Did you get this? Yes or no? Yeah. And I don't want to write this one like this. Why? Because nobody does. You follow me on that? I don't want to use some symbol which is what? Not universal. Clear? Okay. Are you confused? No. Now listen to me. Listen to me. What do I mean by the noise floor? The noise floor is... Noise floor means what? Power. The noise power. Yes? Power. By the way, the noise power, you could also, let's put this one here, SI and what? NI. Clear? I am interested in the noise floor at what? At the input side. Yes? You could always find the noise floor at the what? Output side, because you have the gain. Yes or no? Okay. The noise floor at the input side. Is what? Listen to this. Is equal to K T sub what? S B. Are you following me so far or not? Where T sub S is equal to the what? The system temperature. No response. Yes or no? Okay. And that's equal to what? The TS. TS is equal to what? TA. Yes? Which is what? The antenna temperature plus F. Sorry, let's write it in 2 steps. Plus what? T equivalent. Which is what? The noise equivalent temperature. Question, real temperature or not real temperature? Not real temperature. Real temperature or not real temperature? Real temperature. There's the antenna temperature. Are you following me or not? Okay, and that's equal to what? That's equal to TA plus F minus 1 times what? T naught. Did you get my point? Yes or no? Where F is the what? Is the noise figure of the front end. Yes or no? Minus 1 times what? T0. This is what? This is the room temperature. So the noise floor is the following. Is equal to noise floor, sorry, is equal to K times what? TA plus F minus 1 T0 times what? B. Did you get it or not? Okay. Now, if TA happens to be equal to what? T0, then the noise floor is equal to what? K? Okay, what is it? T0. The T0 will cancel with this T0. So what do you end up with? K. T0. B times what? F. Are you following me or not? Students' mistakes from previous semesters, or even in the industry, when they calculate the noise floor, they always use this equation. Are they always correct or not necessarily? Not necessarily. The equation is this one. This is the noise floor. Did you get my point or not? This is only a special case when the TA is equal to what? T0. When will TA be equal to T0? When is that assumption realistic assumption? When the antenna is indoors. Do you understand that or not? When the antenna is indoors. But if the antenna is outdoor and the receiver is what? Indoors. It's not fair that you say what? You say they are the same because it depends on what? It depends on outside. Is it hot? Is it cold? Or whatever the case might be. Clear so far? Yes or no? Now, once you get the noise floor, you add to it 3 dB to get what? The minimum detectable signal, but that is only if the question does not give you any information about the signal to noise ratio at the input of the demodulator or at the input of the detector. Yes or no? If the question gives you the minimum signal to noise ratio, by the way, minimum signal to noise ratio, for what reason? To provide for what? An acceptable BER. BER, which is the bit error rate. Clear? If the question gives you the minimum signal to noise ratio, you cannot just add what? 3 dB to this one. Did you understand what I just said or not? Measuring this in the real world is easy. Why? Because all what I need is the noise floor. Whereas the MDS is not straightforward. Why? Because the minimum signal to noise ratio depends on what? What type of modulation you are what? Using. Are you following me or not? And you cannot just plug it in an equation. When you simulate or when you calculate the bit error rate, most of the time you need to run what? Simulation. Did you get my point or not? Yes or no? Which will be, by the way, your first project. Running simulation to calculate what? The signal to noise ratio required to achieve certain bit error rate for different modulation schemes. Are you following me or not? And that is why people in the industry, when they calculate the dynamic range, they prefer just to use the what? The noise floor, because it's easier to what? It's easier to find. Are you following me or not? Okay, let's get to the MDS. What is the MDS? Did you understand the noise floor? Yes or no? Did you understand what do I mean by the system temperature? System temperature is what? Is the overall temperature, which includes the antenna and the equivalent noise temperature. What was I going to write? I forgot. Sorry, what is the MDS? The MDS is the minimum signal. No, what is minimum? This is not minimum. Minimum. My English is so terrible. Minimum signal input, signal power needed to generate a minimum given a minimum signal to noise ratio at what? At the output. Output of who? Output of who? Output of the what? The front end. Clear so far? Yes or no? Okay. Now, listen to me. What is SI? Oh, what is SO first of all? What is SO? SO is G. I messed up. No, I did not mess up. SI. Yes? Which means what? SI minimum is equal to what? SO over what? G. Yes or no? Can I write this like this? SO over what? NO. Yes or no? Times what? NO over what? G. Yes or no? Can I write it this way? Now keep in mind, this NO is the what? Is the noise power at where? At the output. Due to who? Due to who? Due to the antenna temperature and due to the what? Internal noise added by the front end. Did you get that or not? Okay. And that's equal to what? SI minimum, which is the what? Which is the MDS, is equal to S over N0 minimum, yes, times, okay, what is N0? What is N0? N0 is what? G times what? Ni. Yes? And the Ni is this guy. Yes or no? Okay, so it's G Ni. Will the G cancels out? Last time I made a boo-boo, the G remained. Did you receive my email? Remove that G, because the G will cancel with this one. So what do you say? SO over NO minimum times what? Ni, which is what? K times TA plus F minus 1 times what? T0 times what? B. Did you get this or not? Not divided by G. Not divided by G. The G is what? Will cancel. Yes or no? Because what? This noise is the output noise power. It's not the input noise power. Whereas this one is the what? Is the input noise power. Did you get this or not? Now, do not put this equation in here unless the question tells you that the antenna temperature is what? Is the room temperature. That's another mistake the students make. Did you get my point or not? Yes or no? Cannot hear you. I see you need to be careful with this. Clear? Clear? Yes? Now, once you get the MDS, then you can go and what? Plug it in here to get what? To get the dynamic range and to get the what? The spurious free dynamic range. Clear? But if the question does not give you the signal to noise ratio, the minimum, just calculate the what? The noise floor and what? Add 3 dB. Or even if you don't want to add 3 dB, it's still okay. Still okay. Are you following that? In other words, you define the linear dynamic range as what? As the input 1 dB compression power minus what? Minus the noise floor. It's still okay. Still okay. You have to always remember, the dynamic range is very hard to what? To characterize or to measure. Do you follow me or not? Because there are many issues involved. Did you understand what I just said or not? Many issues involved. One of the issues, by the way, let me ask you a question. One of the issues, do you see this third order intermodulation component? This, who caused it? Who caused it? There must be what? 2 signals at the input. Yes? In reality, is it possible that we do have multiple signals at the input? The situation will change. This is just what? Theoretical aspects. Did you get my point or not? Now, one last thing before I leave this. We spent too much time on this. But did you get it? Okay, one last thing. What do you plug in here? In here, the bandwidth. What do you plug? You need to plug the what? The channel bandwidth. Are you following me or not? In other words, you need to plug in the what? Remember, this is the front end. Yes? If the last stage before the detector is the what? Is the IF. That should go where? In here. The IF bandwidth. Did you understand that or not? Yes or no? In other words, do not put the what? Remember, the first filter was what? The band select. Yes? You need to put the bandwidth of who? Of the channel select. Yes or no? Why? Which one is wider? The channel select or the band select? The band select. But it does not make sense that you take the band select, even though the noise power increased. But it will not affect the what? The demodulator, because you are going to go through what? The channel select first. Yes or no? No response. Yes or no? Okay, good. Yes.
The MST we found, is it at the input side?
Which one? This one?
Yeah.
This is at the input side. It's SIMN. This is MDSII.
Can we say that SO minimum is the MST at the output side?
You could, but it does not make sense. But you could. You just multiply it by what? By the G. Oh, by the way, I forgot to mention one thing. See this multiplication? This is not in dB. Do you understand that or not? I forgot to mention this. I'm sorry. If you want to make it in dB, this becomes what? Plus. Did you understand that or not? The plus. And you need to change everything into what? In dB. The question, by the way, will give you this already in what? In dB, which means what? You need to change this in dB and then what? Add it together. Clear? Back to your question. The MDSI is usually, the MDS is usually measured from what? from the input side rather than from the output side. Clear? And because it's what? You are talking about what? The minimum received signal. Clear? Clear? Okay. And always keep in mind that this, we assumed what? The third order intermodulation. If the question asks you for the second order, you need to what? You need to modify this. Are you following me on that? Okay, good. Now, we spent too much time on this. But clear? Okay, good. Now, let's start with the next set, which is the part. Link budget analysis. Every engineer, systems engineer, and RF engineers, everybody needs to create what is known as a what? A link budget. After we finish this, I'm going to assign you an extra credit assignment worth 5 points, equivalent to what? The posters. Are you following me on that? I will give you 2 questions on how to build link budgets, and I will ask you to what? Create the Excel sheet. Everything has to be in Excel. Everything has to be in Excel. And the Excel needs to be what? User friendly, very friendly. Are you following me on that? That shows me what? All the budget, the pluses and the what? Minuses. What is a budget to begin with? A budget means what? A pluses and what? Minuses. A pluses means what? You are adding powers, yes, or gains. And what? Minuses means what? You are subtracting. Did you get this or not? At the end, you need to end up with a margin. What does margin mean? If you are in the negative, you are in trouble, like the United States government currently is in trouble because they are in debt. Do you understand that or not? Yes or no? You need to end up with a what? A positive margin for us to say that the link is closed. This terminology, I need you to understand it. When people ask you, is the link closed? What does it mean? Is there a margin on your what? Link budget. Did you get this or not? Yes or no? By the way, if you say the link budget, the margin is 0 dB, we still call the what? The link closed. But you are playing with what? Fire. Why? Why? There are a lot of issues that you will not take into account, and suddenly it what? Pops up. Did you get my point or not? So if you end up with 0 dB, what does it mean? It means you are not leaving any what? Any margin of error. Did you get this or not? Okay, let's see if you can help me. And by the way, I already posted 2 detailed examples. 2 detailed examples on what? On link budget. One is mine, and the other one is from Intersil. Intersil is another company. The one that is mine is so detailed that it will leave no what? Doubt in your mind after you read it, that you know how to create a link budget. Did you get my point or not? The one from Intersil, after you read it, you probably get a headache. Did you answer what I just said or not? So I recommend that you read mine first of all. Clear? Okay. Let's understand first of all, what is a link budget analysis? First of all, I'm going to introduce a new symbol right now, which we have not used so far, which is called what? So far, we have been talking about what? The signal to noise ratio. What is the signal to noise ratio? Signal power divided by what? The noise power. Now I'm going to introduce another, and this one, by the way, is going to cause us what? Severe headache. You will see what I'm talking about. EB over what? N0. This N0 is the what? The power spectral density. Do you understand what I just said? I am sure you are what? You are confused. Are you confused or not? Do you want me to use small n0? I want you to see there is no reason for confusion. I will tell you why. What is this? By the way, you notice I did not put 0 here. Noise power. What is the units of S? Watts. N? Watts. Which means this one is unitless. So is the EB over N0. EB is what? Bit energy. This is the what? Bit energy in what units? Joules divided by what? The power spectral density of what? noise, which is in what? Watts per what? Second. No. Watts per what? Hertz. I messed up. Did you get this or not? You don't need to jump all over me very quickly. Give me some time to recover. You follow me? I made a boo-boo. Give me some time to recover. Are you following me or not? Question. What is watts per hertz? Joules. So what do I get? Joules divided by joules is what? Unitless. You follow me or not? So if you really, if you really want the truth, you should not get confused. Because EB over N0 is what? Is unitless. Clear? The people in the industry, they don't call it EB over N0. They call it what? EBNO. Because it's easier to pronounce. Did you get what more? Yes or no? So if somebody tells you what EBNO, I don't want you to say, I need a dictionary. What does EBNO means? Does not mean EB times N0. It means what? EB over N0. Yes? Are they the same? Are they the same? In other words, are they equal? They are not equal. Let's see. Let's see what they are. So, now which one, by the way, I will be interested in when evaluating the performance of modulation techniques? I will be interested in EB over N0 because I'm going to be interested in digital modulation. And when you talk about digital modulation, you are talking about what? Bit energy, bits. Yes or no? When are you interested in the signal-to-noise ratio? You are interested in the signal-to-noise ratio when you deal with what? Analog modulation. You follow me or not? However, they are related. From the link budget, by the way, I'm not going to be able to get EB over N0 without, first of all, dealing with what? Signal power. Because that is what I'm radiating. Yes or no? Okay, help me. What is the relationship? EB over what? N0. Let's understand. What is the bit energy? Is the what? Is the signal, yes, divided, signal power, signal power times what? Times what? Times the duration. Yes or no? Yes. Which means what? S times what? T sub what? B. What is T sub B? What is T sub B? Is the bit? Somebody said the bit rate. Is the bit what? Duration. Yes or no? Okay. What is N0? Let's see if you can tell me. Remember what I told you. This is N0 over what? 2. Yes? No response. Okay. Now let's assume that our system is band limited. What is the noise power? What is the noise power? The noise power is N0 times what? B. Do you understand that or not? Why? Because to calculate the noise power, you need to what? You need to calculate the area under the curve for both negative and positive. Yes or no? So what is N0? N0 is what? Is N over what? B. What is this N? What is this N? That's the noise power. And the B, of course, is the what? Is the bandwidth. Clear? Now what is this equal to? This signal to noise ratio times what? The bandwidth over the what? The bit rate. RB is called the what? Bit rate, which is equal to what? 1 over what? TB. Did you get it or not? Yes? Or if you want to write it like this, signal to noise ratio is equal to what? EB over N0 times what? RB over what? B. It's the other way around. The signal to noise ratio is clear so far. Question. Could they be equal? For binary modulation, we will see that the bandwidth is the same as what? The bit rate, which in this case you are ending up with what? Signal to noise ratio is what? EB over what? N0. Clear? What did we call RB over W? Or RB over W? Sorry, RB over B or W? W means what? The bandwidth. Did we give it a name? First of all, what is the units of this guy? The units of this guy. Bits per second per hertz. Did we give it a name? Yes. What did we call it? Don't tell me we called it bits per second per hertz. We gave it, that is one of the what? A criteria that you measure modulation techniques with. This is what, this is what is referred to as what? The bandwidth efficiency. Measured, and did we talk about this before? There's no doubt in my mind. Bits per second per hertz. The larger this term is, what does it imply? It implies that the modulation is what? Bandwidth efficient, rather than what? Power efficient. Yes? If this is larger than 1, then S over N is not equal to EB over N0. Did you get my point? Yes or no? Okay, good. Now, when you generate, what number is this? Oh. When you generate the bit error rate, I'll get to the link budget in just a second. What do you write? You sketch this curve. This is what? EB over what? N0. And this one is the what? Is the bit error rate. The probability of what? Bit error. Clear? This will be your first project. I'll give you different techniques. I need to make sure you know how to simulate. Anybody tells me how does the curve look like? The curves look like the what? The Niagara Falls. Did you understand that or not? Cannot hear you. Now listen to me. Let's assume this is 10 to the minus 5. What is this? Tell me, what is this? This is EB over N0 required. R stands for what? Required to achieve bit error rate of what? 10 to the minus 5. Cannot hear you. Yes or no? Now listen to me. Listen to me, because that's the point that I will try before I show you the link button. When I say, notice by the way, if you are willing to settle for a bit error rate, first of all, what is 10 to the minus 5 means? 10 to the minus 5 means what? Single bit in every what? 100,000. Yes? If you want to settle for 10 to the minus 4, where are you moving? You are going to move over this curve, which means what? The required EB over N0 becomes what? Less. Which means what? You need less power to achieve what? To achieve the same bit error rate. Yes or no? I want you to see this. EB over N0. A. I'll explain to you what A stands for. Minus EB over N0 R. One more time. What does the R stands for? What does the A stands for? No, not actual. Available. Available from who? Available from who? Where are we going to get this from? That is from the link budget. Did you get this or not? Cannot hear you. That's from the link budget. Question. Where am I getting this from?
From the requirement.
What requirement? The requirement will give it to you in bit error rate. The requirement does not tell you what is EB over N0. You mean the spec?
Yeah.
When you said requirement, I'm assuming you would say spec, right? The spec will tell you what? The bit error rate should be what? Should be at least what? 10 to the minus 5. Does not tell you EB over N0. Did you understand what I just said or not? How do I get EB over N0? Two ways. One way is to plug in a theoretical equation. Yes or no? For example, listen to this. For example, in PBSK, what does PBSK stands for? Binary phase shift keying, the probability of bit error is equal to Q, this is the Q function, I will send you the tables shortly, to EB over what? N0, close the bracket. Did you understand what I just said? This you studied in communications classes. Yes, this is not this class. Are you following or not? What do I call this equation? That's a cookbook equation. You understand what cookbook means? What does it mean? I got it from a book. That's why they call it a cookbook. Did you get my point or not? That EB over N0 inside the argument, which one of it? That's this one. Did you understand what I just said or not? Yes or no? However, if you do not have the equation, and most of the time, modulation techniques are what? Complicated analytically, that it is not feasible to find a what? A closed form equation, then you need to do what? You need to do simulation. Did you understand that or not? You need to simulate the system. Clear? Yes or no? Once you simulate the system, that is the required. The link budget will not give you the required EB over N0. The link budget will give you the what? The available EB over N0. Yes or no? Which one should be bigger? The available. The difference between them is the LM. What is the LM stands for? Link margin. Clear? No response. Clear? That needs to be what? Positive. Are you following or not? Now you might say, Professor, can I make the link margin 20 dB? It's not a game. Do you understand why it is not a game? If you are making this 20 dB or even higher than that, what does it mean? It means that you are spending too much what? Too much power for no reason. Are you following me or not? For no reason. The required bit error, in other words, for 10 to the minus 5, listen to me. Anybody knows what this value is? For 10 to the minus 5? I don't expect you to remember it. But if you put the equation, you will get what? 9.6 dB. Yes? If it is 9.6 dB, will it make sense that you will build your budget such that EB over N0 available is 30 dB? 9.6 is good enough. You are building that much margin. What will happen? That's Armageddon. What will happen? Nothing will happen. It might rain sometimes. It might what? Some in urban environment, the signal could be degraded severely, whatever. But not by that much. Do you understand that or not? Cannot hear you. So if you tell me I ended up with a link margin which is extremely what? High, I tell you don't brag about it. Don't brag about it, because that means what? You are spending what? Money. Did you get my point or not? Yes or no? Okay, good. Now, let's get into the details. The link budget analysis. We start, first of all, with the following assumption. Assume an isotropic antenna. Question: what does isotropic means? An antenna that what? Radiate in all what? In all directions. Are you following or not? In all directions. The gain is what? Antenna gain is what? Is 1. Are you following me or not? And let's assume it is what? Generating power, piece of what? T. PT stands for what? The transmitted power. The power density is PT over what? 4 pi r square. I want you to understand where this equation came from. What am I assuming? I am assuming that the antenna is at the center of a what? Sphere with a radius of what? The radius of the sphere is what? Is r. And I'm measuring the power density, units. This is not power spectral density. They just what? The power density. It's what? It's watts meter square or kilometer square or mile square, whatever the case might be. Did you get this or not? And I'm measuring the power density at where? At the surface of this sphere. Clear? 4 pi r square is what? Is the area. Yes or no? Okay. But that is only if I'm using a what? An isotropic antenna. Now, if the antenna has directivity, what does that mean? Directivity means what? Means the antenna will have some what? Gain. So we define the gain of the antenna as what? 8 times what? D. Where D is the what? Is the directivity. Question. The more direct the antenna is, the gain higher or lower? Higher. Are you following me on that? And 8 is the what? Is the efficiency. Now, if the question does not tell you anything about the efficiency in our course, you assume it's equal to what? It's equal to 1. But in reality, the efficiency is maybe what? 0.55, 0.6, and something like that. Did you get this or not? Yes or no? Okay. D is equal to what? 4 pi times what? AE, I'll explain to you what AE stands for in just a second, divided by what? Lambda square. Are you following me so far? Yes or no? Where this is called what? The effective area. Are you following me so far or not? Yes or no? I want you to see in this equation very important thing that I need to emphasize. As we will see in just a second, the power is going to be reduced while the signal propagate over the what? Over the air, over the free space, as the distance increase. What is the distance here? What is the distance? Distance is here. Are you following me or not? We will see also that the higher the frequency, the degradation is what? Higher. Yes? Cannot hear you. Why? Why? Not because of what? Not because of the propagation over the free space. Propagation of free space should not depend on what? Should not depend on the frequency. Do you understand that or not? But because of what? Because of this term, the directivity of your antenna. Are you following me or not? The geometry of the antenna. Did you understand what I just said or not? Yes or no? Which means, what do I have now? The power, this is a power density. Yes? Cannot hear you. So it's what? The D, let's assume, by the way, assume the D, assume the eta is what? Is 1. Which means what? This is the gain. Yes or no? So what do I have? Received power. This is the received power. Is equal to, I'm still waiting, PT, yes, times what? GT. This is the what? Antenna gain. At where? At the transmitter side. Yes or no? Times what? But what is GR? Let's write first of all, GR. Yes or no? Over what? I want you to see something. So you lost me here. Okay. What is the D here? What is the D? I want you to look at the D here. What is the D? The D, where is the D? D is the what? Is the gain. Do you understand that or not? Which means the gain is what? Is what is the lambda, by the way? Yes or no? So what is this? C square, and the F square becomes in here. Yes or no? Okay, so what do I have now? PT, GT, GR over what? 4 pi. R over what? Lambda, the whole thing what? Square. Tell me where is this term is coming from? Where is this term is coming from? The 4 pi r square. Now, you see this 4 pi r square? This power density is going to be what? Incident on what? On the receiver antenna, on the area. Yes or no? If I want to calculate the what? The watts. This is watts per meter square. What do I need to multiply it with? I need to multiply by the effective area of who? Of the receiving antenna. Which is what? What is the effective area? Is lambda square times what? G. Why G? Because I'm assuming that the efficiency is what? 1. So it's what? Lambda square times what? G of what? R divided by what? 4 pi. Yes or no? Yes. So what do I have here? One more time. Lambda square times what? G over what? 4 pi. The 4 pi with this 4 pi becomes what? 4 pi square. Yes or no? Yes. The R is this R square. Where did this term come from? This one is here. One more time. What am I multiplying this with? No. Which term am I multiplying it? A sub E. Let me rewrite A sub E. A sub E is what? Lambda square times what? D over what? 4 pi. I'm multiplying this term with this term. Yes or no? Notice, by the way, after you multiply by what? GT. Yes or no? GT is the transmitter antenna. By the way, before we get into any further, PT, GT. There's a name for it. ERP. What is it? What it stands for? ERP. I don't want you to say ERP and you don't. If somebody asks you what it stands for, you tell me what. I don't know. Effective. Isotropic. Radiated power. Clear so far? Yes or no? Cannot hear you. What does it mean when I say effective isotropic radiated power? It means PT times GT. One more time. What is GT? Did I define GT? No, I did not. GT is the transmitter and then again. Excuse me. And then again. Yes or no? Which means what? As if I have a what? An isotropic antenna, but with total power of what? PT times what? GT. Did you get this? When we started this, what was it? Isotropic antenna, an isotropic antenna in all direction, yes? This is what? This is the power density. Yes or no? Now I'm showing what? I'm going to assume that the antenna is not what? Isotropic. So I need to multiply by what? GT. Yes? But that is equivalent to what? An isotropic antenna radiating at what power? PTGT with gain of what? 1. Did you get my point or not? Yes or no? That is called ERP. So now, what is the relation? One more time. Let's write it down. PR equal to PT GT GR divided by what? 4 pi R over lambda square. Answer me the following question. As R, what is R? I know, but I want you to say it in terms of the word R, the letter R. Range. R is the what? Range. Which is the distance between the what? The transmitter and the what? Receiver. Now, one thing that I need you to understand is that if we have an antenna like this an antenna like this is the base station, for example, and this is the mobile station. In reality, the R should be this one. Did you get this or not? Okay, but most of the time they just measure this one easier. Did you get my point or not? But in reality, it should be this. Clear? Anyway, let's not worry about that. Okay, good. Now, what do you notice? As R increases, as the range increases, the received power decreases. That's one thing. Second thing, as the frequency increases, PR what? Decreases. Notice, by the way, it's not linear. It is what? Non-linear, because there is a square. Yes or no?
Yes.
And even this square is very optimistic.
Yes.
What does it mean? It means I am assuming that it is a free space. If you are communicating in an urban environment, dense urban, like downtown LA, are you following or not? Probably this one will be what? 3.5 or 4, or even higher. What does it mean? What does it mean? To get the same received power using what? Free space, the range needs to be what? Reduced. Did you understand that or not?
Yes.
And that is one of the reasons why they make the cells in downtown LA or in a dense urban environment smaller and smaller. Yes or no? Because there is a lot of obstacles and the multipath is what? Is so bad. Yes or no? Whereas in a rural environment, when you drive to Las Vegas, is that rural environment? A freeway to Las Vegas, it's rural. No ocean, no nothing. Yes, it's a rural. Until you get to Sin City, of course, and then what? It's everything is there. Did you get my point or not? Yes or no? You are hiding behind the computer. I don't want you to sit behind the computer. I don't see you because you are hiding. Okay. What was I saying? I forgot. This model is okay. Did you get this or not? Over a satellite link, this model is still okay. Why? Because your ground terminal is facing the what? The satellite, which means the surrounding buildings will not have much of an effect on what? On the transmission. So this one is okay. But for what? Cellular communications, 535. How many of you are taking 535? You will see the professor will tell you what? This model might not be what? Appropriate. You need to what? You need to increase this. And to cover the same range, you need to transmit at a what? Higher power. And use what? More directional antenna. You follow, so that you increase the gain. Clear? What do I call this equation? That is called the Friss, the link equation. Yes or no? Cannot hear you. I'll get back to the charts in just a second. Please. Are you following me? Yes. Question. Is the actual, by the way, am I going to get this from the link budget? I will get this one in the link budget, of course. Yes? But when I write it, I will write it in what? In dB. Link budget, everything is in dB. Okay, so what do I have? PR equal to PT plus GT. What is the units? Units.
DBM.
DBM or dB watt. I mean, don't assume that it's always DBM. When you are transmitting over a satellite link, you are not going to use DBM. You need what? High power to reach the satellite in a geosynchronous orbit. So it will be dBW. Don't assume that's always dBm. Clear? Okay. So dB watt or dBm. dB. dB. What is LF? LF is called the free space loss. In what? In dB. This is equal to 32.4 plus 20 log F plus 20 log R or D. Are you following me or not?
Yes.
Where did this equation came from? This equation is this one. Are you following me or not? But you take the log. Yes or no? But be careful. This F is in what? Megahertz. So for example, if the question tells you you are using, let's say, the KU band in a satellite. The KU band is what? 12 gigahertz. What do you plug here? You plug in 12,000. Did you understand what I just said?
Yes.
Yes or no? It's in megahertz. And this R is in what? In kilometer. Did you understand what I just said or not? Yes or no? This in kilometer. For example, if you are looking at the link to a geosynchronous satellite, what do you plug here? 36,000. Don't write 36,000 times 10 to the 3. It's already in kilometer. Did you get this or not? Whatever you get in here, you need to put a what? A minus sign. In the budget, when you are creating the Excel, some of the entries will be plus, some of the entries will be what? Minus. Did you get this or not? That's why I told you the budget is a what? It's a plus and minus. Did you get my point? Okay. Now, is the actual received power this, or in reality it's lower than this? It's lower than this. Why? Because in this equation, I am only taking into account the losses that are introduced through the propagation over free space. There are other problems. One problem being the what? If there is a mismatch between what? The antenna and the receiver front end, mismatch, impedance mismatch, you need to include the degradation. Yes or no? If there is a what? Mismatch in the polarization between the transmitter and the what? The receiver antennas, you need to take that into account. If it rains, like where? In Florida or in what? In the Northwest. Like what? Seattle. Most of the time it's raining there. You need to take it into account. That is not a free space loss. Do you understand that or not? You need to include the rain loss. You need to include the what? The gaseous loss, if there are gases in there. Hardware implementation, that's the impedance mismatch. The IQ mismatch. Did you understand what I just said or not? Some of them, of course, when you prepare the link budget, you might not have it right away because you have not built the system yet. Did you get the point that I'm trying to make? Yes or no? You need to what? You need to assume it. Now, for the gaseous losses, for the what? Rain losses, you need to use some models, published models, empirical models, to what? To put it in the link budget. Did you understand that or not? So in reality, this one here, by the way, how about fading or shadowing? Do you need to put it in the link budget? You need to take it into the link budget. Are you following me or not? Shadow fade, the shadow margin or fade margin. You need to include it in your link budget. You cannot just put what? The free space loss and we say, well, hey, that's good. That looks good. Did you get my point or not? Yes or no? Okay, so good. Let's, by the way, where are we right now? Once we reach this, once you include the GR, where are we? There's the PR at where? At the output of the antenna, because you included the what? The GR, the gain of the receiving antenna. Yes or no? What do I need to calculate next? The noise floor. Yes or no? And I just showed you how to calculate the noise floor. What do you need to have? What parameters? The antenna temperature. Yes or no? The receiver noise figure. Yes or no? Cannot hear you. And the bandwidth. Did you understand that or not? Cannot hear you. However, if you want to find EB over N0, not the signal to noise ratio, not the signal to noise ratio, your interest in EB over what? N0. Yes? Do we need the bandwidth? Do we need the bandwidth? Do we need to know the bandwidth? We don't need to know the bandwidth. Are you following me or not? Because we are calculating what? We need to know the what? The bit rate to calculate what? EB, yes or no? But we don't need the bandwidth because I don't need to find the noise power. I need to find the what? The noise power spectral density. Yes or no? And what does that mean? This is the noise floor. What parameter do I remove? You lost me here. Did you lose me? You lost me. Do I need the B? If you remove the B, if you have this, what is this? That's the noise spectral density. That's the N0. Not the N0 here. The N0 is power spectral density.
Yes.
You lost me. Did you lose me? You don't need the bandwidth. If your goal is what? If the question is only asking you for what? EB over N0 or the link margin. Yes? But if the question asks you to find the signal to noise ratio, no, you need the bandwidth. Otherwise, how do you calculate the what? The noise power. Clear? Clear? Okay, let's get into some, before we get into the noise, let's get back to the chart. Did you understand this?
Professor, you have 4 minutes left.
Okay, okay. Are you following me or not? Okay, good. Now, let's get into some issue. I'm not going to be able to finish the link budget today. So let's understand some of the issues here. Did you understand this equation?
Yes.
What is the A one more time? Available. From where? Link budget. Required either from what? Cookbook equations or via what? Simulation. This is not coming from the link budget. The difference between them is what? Is a link margin. Clear? And I need to make the link margin at least what? 0.
Yes.
The question, if it is 0, what will it tell you? Listen to this. It will tell you the link is barely closed. When you hear the word barely closed, what does it mean? The link margin is what? 0. Did you get this or not? Good or bad? Bad. You don't design link margins for, but this is what? Remember, this is just it's a project. Are you following me now? This is not a real link budget in the real world. This is fantasy. Did you understand what I just said or not? Okay, good. Oh, the signal to noise ratio again of the average signal power to the noise. Where is the noise coming from? Look at where the noise coming from. Thermal noise, atmospheric noise, systems non-linearity, interference, both intentional and what? Intentional means what? Jamming and what? Non-intentional. Non-intentional include the what? CCI and what? ACI. One more time. CCI stands for what? Co-channel interference. ACI? Adjacent channel interference. Or self-interference. What is self-interference? You are going to interfere with who? Yourself. This is what we refer to as what? ISI. What does ISI stands for? The intersymbol interference. Yes? Remember, intersymbol interference will happen. We will see it in detail shortly. It will happen when you transmit at a faster rate on a what? On a band limited channel. In other words, the filter bandwidth is less than the what? The rate at which the signal is what? Is transmitted. It cannot what? It cannot keep up. Did you get this or not? I want you to see at the transmitter. This is the transmitter information. This is the modem. This is transmitter. All types of what? Losses. Limiter losses. What does limiter losses mean? If you are transmitting using what? FM, which is what? The amplitude is supposed to be what? Constant. Sometimes you will see some variations in the amplitude. You need to use a what? A limiter to cut them off. That's the limiter loss. LO phase noise. Local oscillator phase noise. Yes or no?
Yes.
Generating all types of spurs. ISI, band limiting loss. We already, IM products. AMPM. What does that mean? Amplitude modulation to what? Phase modulation, which means what? The input is an amplitude modulation signal, but because of nonlinearity, the output phase, see in AM, the phase is supposed to be what? Constant, but the phase will change, which means what? Somehow you created a what? A phase modulation component on the phase, whereas the input is just barely what? AM. Clear? We'll talk about this shortly. Efficiency losses, IM, radome loss. What does that mean? What does the radome means? Anybody? This is the first time you hear it? Or have you heard it before? The first time? You cover the antenna to shield it from what? Temperature outside heavy. You shield your antenna. You follow me or not? This is called a what? A radome. Yes or no? That will introduce losses. You transmit it over the channel, pointer loss, pointing of the antenna. It's not what? Line of sight, for example. Clear? You have what is known as what? Center of what? Center of beam. We call it what? COB. And what? Edge of beam. Edge of beam, EOB. It means what? Remember, the antenna is like this. It's somewhere in here you are going to lose. Center of beam is what? Is here. If you are here, happen to be here, you are going to be pointing to what? Edge of beam. Yes or no? Yes. Pointing losses, polarization losses, atmospheric losses. Polarization means what? The antenna vertical polarization, horizontal, and so on and so forth. Free space loss, pointer loss on the other side. Yes or no? Yes. At the receiver, exactly the same as what? The transmitter, in addition to who? Do I have this at the transmitter side? No, because we have not the transmitter yet. But in here, you do have the what? The CCI, the ACI, the jammers. When you use the word jammers, means what? Intentional jammers. Clear? All of them will result in what? In implementation. All of these by the way, when you see the word implementation losses, means what? Mismatch, impedance mismatches, hardware implementation losses. Yes or no? Yes. All of this, you need to take them into account in the what? In a link budget. Now, of course, when we build a link budget, some of it we will what? Assume it. For example, we say assume the implementation loss is what? 1 dB. Then you discover what? It's more than 1 dB. Did you get this or not? But that's just an assumption. You need to start somewhere. Clear?
Professor, we're out of time.
Okay, good. So we'll continue this next time. But did you get the idea? Yes. Okay, good. Next time we'll continue on this. And this weekend, I will be assigning the extra credit for this weekend. Okay, good.
This concludes today's session of the Impact 44 on Tuesday, February 18, 2014.